Hello everyone, my name is Isan and in this video I'm going to talk about some well-known machine learning and data mining approaches for intrusion detections. So, cybersecurity is a set of technologies and processes designed to protect computers, networks, programs, data, illegal access, and change or destruction against attacks. It composed of network and computer security systems. Each of these has, at a minimum, a firewall, antivirus software, and an intrusion detection system. The security breaches include external intrusions such as attacks from outside the organization, and the internal intrusion that covers threats from within the organization. An intrusion detection system, or so-called IDS, is a network security technology originally built for detecting vulnerabilities exploits against a target application or computer. IDS is based on learning data from machines and computers using machine learning based approaches. It helps discover, determine, and identify unauthorized use, duplication, alteration, and destruction of information systems. Uh, there are there are three main types of cyber analytics in support of IDS: misuse-based, sometimes also called signature-based, anomaly-based, and hybrid-based. Okay, let's introduce each one shortly. Misuse-based techniques are designed to detect known attacks by using signatures of those attacks. They are effective for detecting known type of attacks without generating an overwhelming number of false alarms. They require frequent manual updates of the database with rules and signatures. Misuse-based techniques cannot detect novel or zero-days attacks. The other one is anomaly-based techniques. It models the data network and system behavior and identify anomalies as deviation from normal behavior. Uh, they are appealing because of their ability to detect zero-day attacks. Another advantage is that the profiles of normal activity are customized for every system, application, or network, thereby making it difficult for attackers to know which activities they can carry out undetected. Additionally, the data on which anomaly-based techniques alert can be used to define the signatures for misuse detectors. The main disadvantage of the anomaly-based techniques is the potential for the high false alarm rates because previously unseen system behaviors may be categorized as anomalies. The third type is hybrid IDS. It combines misuse and anomaly detection. They are employed to raise detection rates of known intrusions and decrease the false positive rate, or FPR, for unknown attacks. An in-depth review of the literature did not discover many pure anomaly detection methods. Most of the methods were really hybrid. So, in the description of the machine learning and data mining methods, the anomaly detection and hybrid methods are described together. Uh, Another deviation of intrusion detection systems is based on where they look for intrusive behavior, network-based or host-based. A network-based intrusion detection system identifies intrusions by monitoring traffic through network devices. A host-based also monitors processes and files activities related to the software environments associated with the specific host. Okay, machine learning and data mining are the foundation of the intrusion detection systems. There are three main types of machine learning and data mining approaches: unsupervised, semi-supervised, and supervised. In unsupervised learning problems, the main task is to find patterns, structures, or knowledge in unlabeled data. Uh, when a portion of the data is labeled during acquisition of the data or by human experts, the problem is called semi-supervised learning. The addition of the labeled data greatly helps to solve the problem. If the data are completely labeled, the problem is called supervised learning, and generally the task is to find the function or model that explains the data. The approaches such as curve fitting or machine learning methods are used to model the data to the underlying problems. There is a significant overlap between machine learning and data mining. These two terms are commonly confused because they often employ the same method and therefore overlap significantly. The pioneer of machine learning, Arthur Samuel, defined machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. Machine learning focuses on the classification and prediction based on noun properties previously learned from the data label. From the training data. Machine learning algorithm need a problem. It needs a problem formulation from the domain like a dependent variable to predict. On the other hand, data mining focuses on the discovery of previously unknown properties in the data. Actually, it doesn't need a specific goal from the domain, but instead focuses on the finding new and interesting knowledge for some purposes. Each of the machine learning and data mining has its own specific steps. For machine learning, the steps are identifying class attribution or features and classes from training data. Thereafter, identifying a subset of the attribute necessary for classification, such as dimensionality reduction. Next step is to learn the model using training data, and finally using the trained model to classify the unknown data. In the case of misuse detection, in the training phase, each misuse class is learned by using appropriate exemplar from the training set. In the testing phase, next data are run through the model, and the exemplar is classified as to whether it belongs to one of the misuse classes. If the exemplar does not belong to the misuse classes, it is classified as normal. In the case of anomaly detection, the normal traffic pattern is defined in the training phase. In the testing phase, the learned model is applied to new data, and every exemplar in the testing set is classified as either normal or anomalous. In sense of data mining, the model is composed of the 6 phases. Business understanding, which defines the data mining problem shaped by the project requirement. And the data understanding, which means data collection and examination. The next step is data preparation to reach the final data set. Modeling is the next step that defines applying data mining methods and optimizing parameters to fit the best model. In the evaluation step, it's evaluating the method with appropriate metrics to verify business goals are reached. And finally, in development, it varies from submitting a report to a full implementation of the data collection and modeling framework. Usually, the data analyst engages the phase until deployment, while the customer performs the deployment phase. For machine learning and data mining approaches, the data is one of the great importance. Because these techniques learn from the available data, it's necessary to have an understanding of the data they use in order to understand how different others apply different machine learning and data mining algorithms. There are 3 main dataset categories which are commonly used in intrusion detection systems. By the way, since I have no time in this video, I will move on quickly. You can stop the video and read the details of each category if you're interested. First category is packet level data, which contains network packets with IP headers and IP payloads. The second one is called net flow, which is composed of sequence of packet features and IP headers. And finally, public data such as DARPA, KDD, UNM, and recently published dataset called ADFA. Alright, let's move on and talk about common machine learning and data mining approaches for intrusion detection. The first approach, which I'm gonna shortly talk about, is artificial neural network, so-called ANN. ANNs are inspired by the brain and composed of interconnected artificial neurons capable of certain computation of their inputs. The input data activate the neurons in the first layer of the network, whose output is the input to the second layer of neurons in the network. Similarly, each layer passes its output to the next layer, and the last layer output is the result. Layers in between the input and output layers are referred to the hidden layers. When an ANN is used as a classifier, at the output layer generates the final classification category. ANN classifiers are based on the perceptrons and were very popular until the 1990s, when support vector machines were invented. Compared to the convex quadratic optimization applied in an SVM, ANNs often suffer from local minima and thus long run times during learning. Unlike an SVM, as the number of features in ANN increases, its learning runtime increases. With one or more hidden layers, the ANN is able to generate nonlinear models. The backpropagation feature of the ANN makes it possible to model XOR logic. With development in this field, such as recurrent, feed-forward, and convolutional neural networks, ANNs are gaining in popularity again, and at the same time winning many prizes in recent pattern recognition contests. Because the advanced version of ANNs required even more processing power, they are implemented commonly on graphic processing units or GPUs. The next approach is Bayesian network. A Bayesian network is a probabilistic graphical model that represents the variables and the relationship between them. The network is constructed with nodes as the discrete or continuous random variables, and directed edges as the relationship between them, establishing a directed cycle graph. The child nodes are dependent on their parents. Each node maintains the states of the random variable and the conditional probability form. Bayesian networks are built using expert knowledge or using efficient algorithms that perform inference. Here's an example of a Bayesian network for attack signatures detection. As you can see, each state can be an input to other state with certain set of state values. For example, the protocol state can pick values from available protocol numbers. Each of the state values that can go from a state to another state have an associated probability, and the sum of those probabilities will add up to one representing the entire set of state values. Depending on the application, the network can be used to explain the interplay between the variables or to calculate the probable outcome for a target state using the input states. The probability table can be calculated from the available training data. Inferring on observed variables, parameter learning, and structural learning are among the main tasks for training Bayesian networks. Clustering. Clustering is another technique in developing an intrusion detection systems. Clustering is a set of techniques for finding patterns in high-dimensional unlabeled data. It's an unsupervised pattern discovery approach where the data are grouped together based on a similarity measures. The main advantage of a clustering for intrusion detection is that it can learn from other data without requiring the system administrator to provide explicit description of various attack classes. There are several approaches for clustering the input data. In connectivity models like hierarchical clustering, data points are grouped by the distances between them. In centroid models like k-means, each cluster is represented by its mean vector. In distribution model like expectation maximization algorithm, the groups are assumed to be acquisition to a statistical distribution. Density models group the data points as dense and connected regions. And lastly, graph models like clique define each cluster as a set of connected nodes or data points where each node has an edge to at least one other node in the set. Clique is a completely connected subgraph of a graph. In the clique method, each maximal clique in the graph becomes a cluster by itself. An instance-based learning, also called lazy learning algorithm, the KNN, is another popular machine learning method where the classification of a point is determined by the k nearest neighbors of that data point. Determining the category of the point exercises a majority voting, which can be a drawback if the class distribution is skewed. Because high-dimensional data affect the KNN methods negatively, thus the feature reduction is almost always required. The choice of the neighborhood order or the order in the dataset is also considered to have high impact. Among the benefits of KNN is its simplicity and absence of parametric assumptions, although for sure except the number of k's or neighbors. Other well-known approach is decision tree. A decision tree is a tree-like structure that has leaves which represent classification and branches which in turn represent the conjunction of features that lead to those classifications. An example is labeled by testing its feature values against the nodes of the decision tree. The best known methods for automatically building decision trees are the ID tree and C4.5 algorithm. Both algorithms build decision trees from a set of training data using the concept of information entropy. When building the decision tree at each node of the tree, C4.5 chooses the attributes of the data that most effectively splits its set of examples into subsets. The splitting criterion is the normalized information gain, or in other words, difference in entropy. The attribute with the highest normalized information gain is chosen to make the decision. The C4.5 algorithm then performs recursion on the smaller subset until all the training examples have been classified. The advantage of decision trees are intuitive knowledge expression, high classification accuracy, and simple implementation. The main disadvantage is that for data including categorical variable with a different number of levels, information gain values are biased in favor of feature with more levels. The decision tree is built by maximizing the information gain at each variable split, resulting in a natural variable ranking or feature selection. Small trees have an intuitive knowledge expression for experts in a given domain because it is easy to extract rules from those trees just by examining them. For deeper and wider trees, it's much more difficult to extract the rules, and thus, the larger the tree, the less intuitive its knowledge expression. Smaller trees are obtained from bigger ones by pruning. Larger trees often have high classification accuracy but not very good generalization capabilities. By pruning larger trees, smaller trees are obtained that often have better generalization capabilities. Decision trees building algorithms are relatively simpler than more complex algorithms such as SVMs. As such, they have also a simpler implementation. In general, supervised learning algorithms search the hypothesis space to determine the right hypothesis that will make good predictions for a given problem. Although good hypotheses might exist, it may be hard to find one. Ensemble methods combine multiple hypotheses, hoping to form a better one than the best hypothesis alone. Often, ensemble methods use multiple weak learners to build a strong learner. A weak learner is one that consistently generates better prediction than random. One of the ensemble algorithm uses boosting to train several weak learning algorithms and combine their weighted results. Adaptive boosting, or so-called ADA boost, is one of the more popular algorithms used to reduce the overfitting problem inherent to machine learning. Boosting can be seen as a linear regression where data features are the input to the weak, and the output of the boosting is the weighted summation of these functions. Some researchers criticize boosting by suggesting that a non-zero fraction of the mislabeled data can cause boosting to fail completely and result in an ROC of almost 0.5. Bagging is a method to improve the generality of the predictive model to reduce overfitting. It is based on a model averaging technique and known to improve the one nearest neighbor clustering performance. And last but not least, stacking is similar to boosting. which also applies several models to the original data. The difference here is, however, that you don't have just an empirical formula for your weight function. Rather, you introduce a meta level and use another model to estimate the input together with output of every model to estimate the weights, or in other words, to determine what models perform well and what badly given these input data. One well-known ensemble classifier, random forest. The random forest classifier is a machine learning method uh, uh, that uh, that combines the decision trees and ensemble learnings. The forest is composed of many trees that use randomly picked data features or attributes as their input. The forest generation process constructs a collection of trees with controlled variance. The resulting prediction can be decided by majority voting or weighted voting. Random forests have several advantages, such as a low number of controls and model parameters, resistant to overfitting, no requirement for feature selection because they can use a large number of potential attributes. One important advantage of random forest is that the variance of the model decreases and the number of trees in the forest increases, whereas the bias remains the same. Random forests also have some disadvantages, such as low model interpretability, performance loss due to correlated variables, and dependence on the random generator of the implementation. And now, support vector machines, or SVM. SVM is a commonly used technique for researchers who are focused on machine learning based stuffs. The SVM is a classifier based on finding a separating hyperplane in the feature space between two classes in such a way that the distances between the hyperplane and the closest data points of each class is maximized. The approach is based on the minimized classification risk rather than an optimal classification. SVMs are well known for their generalization ability and are particularly useful when the number of features is high and the number of data points is low. When the two classes are not separable, slack variables are added and cost parameter is assigned for overlapping data points. The maximum margin and the place of the hyperplane is determined by the quadratic optimization with the practical runtime of O n power of 2, placing the SVM among fast algorithms even when the number of attributes is very high. Various type of dividing classification surfaces can be realized by applying a kernel, such as linear, polynomial, Gaussian radial basis function, or hyperbolic tangent. SVMs are binary classifiers, and multiple class classification is realized by developing an SVM for each pair of classes. And thank you everybody for watching this video. I would provide the longer version of this video, which covers few more approaches and includes example of case studies for each approach for both misuse and anomaly based systems.